So hello everyone, welcome back to the channel. Today we are going to solve the problem Wi-Fi range. So there are n rooms in a straight line in Geekland State University's hostel. You are given a binary string s of length n where si is equals to 1. Represent that there is Wi-Fi in ith room, or si is equals to 0 represent no Wi-Fi. Each Wi-Fi has range x, and if there is Wi-Fi in ith room, then its range will go up to x more room on its left as well as right. Okay, so you have to find whether students in all room can use Wi-Fi. Really easy question, just a small observation required. So let's understand. So now we are given string s, okay. Si is equals to 1 denote that at ith index there is Wi-Fi. Okay. Also, if at ith index there is Wi-Fi, that means x elements before it and x elements after it can access this Wi-Fi. Okay. So that means this Wi-Fi will be available to x element at left, x element at right as well. Okay. And if si is equals to 0, that means no Wi-Fi. We have to check if all indices is Wi-Fi network, any of Wi-Fi network is available. At least one Wi-Fi network is available. That we have to check. If at all indices, at least one Wi-Fi network is available, we have to return true, else obviously false. So let's see. Let's say we are x is equals to 2. So we'll say there is no Wi-Fi, no Wi-Fi. Okay. But when I come to this, that means here is a Wi-Fi. That means if x is equals to 2, that means two elements before it and two elements after it has Wi-Fi. Then, okay, so that means it has Wi-Fi, it has already Wi-Fi because, and this is Wi-Fi. Okay, so two elements after it, two elements before it has Wi-Fi. Okay, similarly, let's come to this. Let's say, let's say it is Wi-Fi. Okay, now this has, let's say, Wi-Fi 2. So it will have Wi-Fi 2. So two element before it will have Wi-Fi 2. So it will have also Wi-Fi 2. It will have also Wi-Fi 2. And similarly, two elements after it also has this Wi-Fi access available. So Wi-Fi 2, Wi-Fi 2. So I will say that at every point, at least one Wi-Fi is available. So answer will be true here. Let's check for this test case. Okay. So here we can see here is 1, but x is equals to 1. I have modified something like that. So let's say here is Wi-Fi 1. So Wi-Fi 1 will be available here. Wi-Fi 1 will be available here because one element left, one element right. Similarly, here is 1. That means let's say it's Wi-Fi 2. So Wi-Fi, one element left, one element right. Now you can see all indices have no one. So you can see these three indices have no access to any of the Wi-Fi. They have not even at least one Wi-Fi network. So we will say this is false. So this is the question. So how to approach this question? So before that, let's see very basic technique. So basically, I have just kept this name as range frequency technique. There is no name for that. Okay. So before going to this technique, let's see one thing. Let's say I have ranges 1, 2, 1, 3, and another range is 2, 4. Okay. And let's say I want that all elements from 1 to 3 increment by 1. Similarly, all elements from 2 to 4 increment by 1. Okay. So let's say I go for 1 to 3. So I will take a loop plus 1, plus 1, plus 1. Let's say it's initially 0. So it will be become 1, 1, 1. Okay. Now next time when I come to this 2, 4. So I will say, okay, let's again 2 to 4 run a loop and make it plus 1. This will become 2, this will become 2, and this will become 1. So we can see like this. Okay. So we can do it like this. Okay. This is what? That for every range, I am taking what? A big of n loop. So you can say if range is big of n, so this is big of n square. So actually, we have to optimize this thing. Okay. So how we optimize? Just using this technique. Okay. So the technique is something like that. I've kept this name. This is not actually a technique. So if I take, let's say I have a range L comma R, just see L comma R. So we will say frequency of L plus plus, frequency of R plus 1 minus minus. Okay, just do this. So let's say I take this array again, 0, 1, 2, 3, 4, and let's take one extra size for that. Okay, so just take this. And let's say I have 1, 3 again. So I will do for 1, 3, L comma R, frequency of 1 plus plus. Let's say initially all the frequencies are 0. And frequency of 3, R plus 1 minus minus. That is 3 plus 1, 4 minus minus. So I will say frequency of 1 will become 1. Frequency of 4 is 0. So 0 minus minus will become minus 1. Okay. Similarly, let's say I take this range 2, comma 4. So this will become frequency of 2 plus plus and frequency of what? R plus 1. That is 4 plus 1 minus minus. So I will say frequency of 2 will become 1 from 0 plus plus will become 1. Similarly, frequency of 5 will become minus minus. It was initially 0. It will become minus 1. Now after doing this thing for every range, now just traverse the array and take prefix sum. Just see, you will observe this thing. Okay. So now if I take this prefix sum is 0, so this is prefix sum is 1, prefix sum is 2 because 1 plus 1 plus 0 is 2. prefix sum is 2 again. Prefix sum is 2 again. And here prefix sum will be 1. Here prefix sum will be 0. Okay. Now you can see this is matching. This is matching. How it's matching? So I will say, let's say I have frequency of L plus plus. That means if I have increment this by 1, that means it will be when I traverse array, I will passing this one add plus 1 plus 1 plus 1. But when I come to this 4, because I have 1, 2, 3. So I will say plus 1 for 1, plus 1 for 2, plus 1 for 3. But not plus 1 for 4, 5, 6. No. I want only plus 1 for 1, 2, 3. When I pass this, let's say I plus 1. So this plus 1 will pass add. This plus 1 will pass add. But when this plus 1 pass add, I will subtract minus 1 so that this will become null and it will become 0. Because I don't want to pass this plus 1. So this is the technique in big O of 1. What I'm doing, I am doing frequency of L plus plus and frequency of R plus 1 minus minus. How? Because for every range, I have 1 to 4. So I will say for 1, 2, 3, 4, yes, it's fine. But when I come to 5, 6, 7, 8, I don't want to take this plus 1 for them. So when I pass this plus 1, add, and add, then when I come to this 5, I will say minus 1. That's why I'm doing frequency of R plus 1 minus 1. So when I take prefix sum, so this plus 1 will cancel out here and it will become 0 and 0 will be passed. So this is something like trick. Okay. So we are going to use this trick here. So let's see the approach. Very easy approach. Okay. So if so let's see. Like let's say I have 0 here. So I will not do anything. 0 here. I will not do again anything. I have 1 here. Okay. So I will say okay. So any element, any two element before them, any two element after them will have access to Wi-Fi. So I will say what I have to do. What I have to do, let's say I am at ith index. So I want from I minus x to I plus x should be incremented by 1. That means there is at least one Wi-Fi here. Okay. So what I will say, frequency of I minus x plus plus. Okay. So just consider that this is L. Okay. Let's consider better way. This is L. This is R. Okay. Because actually what is L? L is I minus x and R is I plus x. That means every element will have access to Wi-Fi. Okay. So I will say plus 1 for all. So instead of doing this, just doing big O of one approach. What? Frequency of L plus plus, frequency of R plus 1 minus minus. So what I will say, frequency of L become plus plus and frequency of R plus 1, that is this index, will become minus minus. So this will become minus 1. This is the frequency that I'm maintaining here. Okay. Now, let's move to add 0, 0, 0. Doesn't matter. So now let's come to this one again. Now when I come to this one, so I will say, okay, but let's say this is the index. Okay. So I will go to I minus x, I plus x. So I will say I minus x plus plus and I plus x, I plus x plus 1 minus minus. So let's say here is 0. It will become minus 1. Okay. Now you can see like here is that. Okay. Now I will take prefix sum as I take. Okay. That means there is a Wi-Fi exists from here to here. Similarly, that is because I have done plus 1 and minus 1. That means there is a Wi-Fi access available here. Similarly, I have done plus 1 minus 1. There is a Wi-Fi access available here. So that is the approach. Just we have range L comma R. And what we are doing, frequency of L plus plus, frequency of R plus 1 minus minus. For every range, whatever, let's say I have 1. So I will say for this range, frequency of L plus plus, frequency of R plus minus 1. Similarly, for this one, frequency of L plus plus, frequency of R plus 1 minus minus. Okay. Because R plus 1 obviously will go ahead. Okay. So what I will say, at the end I will take prefix sum. So obviously at the end prefix sum 1, 1, 1. This will be 2. This will be 1. This will be 1, 1, 1. And this will become 0. Okay. So you can see for 0 to n minus 1, all indices have at least 1. That means there is at least one Wi-Fi that exists here. So I will say this will return true. But somehow, let's say this will become 0 from 0 to n minus 1. Okay. Let's say this is only the range that is giving me greater than or equal to 1. So I will say false. Okay. Because there is no access to, at any index, if I found 0, I will return false. Why? Because there is no access to Wi-Fi at that position. So this is the approach. Okay. So let's try to code up the approach. Now, I will maintain a frequency array. As I already said, while driving the approach, I will be taking extra 0. That means these are indexes till n minus 1. Okay. And I want to take this extra index n. So I will say frequency of n plus 1 is equal to 0. Okay. And then I will traverse the array I less than n I plus plus. Okay. And then if s of I is equals to 1. Okay. So that means left will be what? I minus x And what will be right? I plus x. But this will create some error for some edge cases. What? Let's say, I am here. Let's say I have 0, 1, 0, 0, 0. Let's say this. Okay. Now I am at this index. X is equals to 2. That means I will say two elements before it, but there is no element before it. So I will do frequency of -1 plus plus, which is not possible. So what I will say take, if the element is exceeding, take the first element. So I will say what? Maximum of what? 0, comma, I minus x. What it will do? Let's say we have I minus x. Let's say I have like 0, 0, 0, 1, 0, 0, 0. So obviously this index will be greater than this 0th index. One index will be greater than this. So this will take this index. But if somehow this happens, this exceeds. So obviously I minus x is before. So I will take maximum. So I will take this index only. Okay. Similarly for edge case for right one. So since I plus x can exceed, so I will take minimum of them. I plus x, minimum of them, so that the index doesn't exceed. So minimum of what? I plus x, comma, n minus 1. Okay. So this is what we are trying to do. So left part will be maximum of I minus x comma 0, and right part will be minimum of I plus x comma n minus 1. Okay. Now frequency of left plus plus, this is the range. This is the range. And normal thing, right plus 1 minus minus. Okay. Now we traverse there and just take the prefix sum. Okay. Now we will say if I is greater than 0, then I will be going to take frequency of I is equal to frequency of I minus 1. Okay. And we check if at any point it is equal to 0, that means there is no access to Wi-Fi here. Okay. If it is no access to Wi-Fi, we will return false. And if all of them have access to Wi-Fi, I will return true. Now, what is this range depicting? That there is Wi-Fi from I minus x to I plus x. So this range depicting. So let's try to compare in the code and check whether it is working fine. Yes. So let's submit the code. So yes, it's totally working fine. So the basic thing was to just finding this range, incrementing the range in big O of 1. Just this thing. Otherwise, I will run a loop from for left to right. J is equals to left, comma j less than is equals to right. J plus plus increment by 1. But that will become hectic. Obviously, what I want it in big O of n. It will become big O of n square, obviously. So this was all about code. So if you like the explanation, please like, share, and subscribe to my channel. Thank you and have a nice